Welcome to Asyn Code. Hey everyone. We've got some exciting content today. Please like and subscribe to join the fun. When we talk about allocating memory for structures, we are discussing the process of setting aside a specific amount of memory in the computer's RAM to store data that will be organized in a structure. In programming, especially in languages like C and C++, a structure, or struct, is a way to group together different types of data under one name. This is helpful when you want to represent an object or an entity with different characteristics. This example demonstrates how to define a structure in C to represent a person with attributes such as name, age, and height, and how to allocate memory dynamically for that structure. The program allocates memory for a person object using malloc, assigns values to the person's name, age, and height, prints these values, and finally frees the allocated memory to avoid memory leaks. The goal is to show how to handle memory allocation for complex data types and manage dynamic memory properly, ensuring the program can scale and clean up resources after use. This header is required to use malloc and free for dynamic memory allocation. Define a structure to represent a person with name, age, and height. A character array to hold the person's name, up to 50 characters. A fixed size is chosen here. An integer variable to store the person's age. A float variable to store the person's height in meters, using float for precision. Allocate memory for one person structure dynamically on the heap. Malloc is used to allocate memory. It returns a pointer to the allocated memory block. Size of struct person gives the total size of memory required for one person structure. Struct person asterisk is used to cast the return void pointer to a pointer of type struct person. Check if memory allocation was successful by verifying if P1 is null. Malloc returns null if allocation fails. If allocation fails, the program will print an error message and return 1 to indicate an error occurred. Inform the user about the failure. Return an error code, exiting the program. Assign values to the members of the person structure. Use print to safely assign a string to the name field. Sprintf ensures that we do not write more than 50 characters, the size of name array, avoiding overflow. Assign the name, Alice, to the name field. Assign values to the age and height fields directly. P1-age refers to the age field of the structure pointed to by the P1 pointer. Set the age field to 30. Similarly, assign a value to the height field of the person structure. Set the height field to 1.75 meters afloat. Print out the values of the structure's fields. Use P1-name to access the name field of the structure through the pointer P1. The dash operator is used to access structure members through a pointer, instead of dot, which is used for direct access. Print the name Alice. Print the age 30. Print the height with 2 decimal places, 1.75. After using the dynamically allocated memory, it is important to free it to prevent memory leaks. Free deallocates memory that was allocated using malloc. This ensures that memory is properly released. Free the memory allocated for P1 to avoid memory leaks. Return 0 to indicate successful execution of the program. Now run our code. That's it for today. Like, comment, and subscribe to stay updated with more content.